In this video, we're going to talk about balancing combustion reactions. Now, combustion reactions are a very special class of reactions. When you have a combustion reaction, you have some parent molecule, A, combusting with oxygen. So we specify one of the reactants. It's O2 gas. It is an irreversible reaction. There is never a reverse arrow associated with this. And generally, our combustion products are CO2, gas. We have carbon in the compound, H2O, gas. If we have hydrogen in the compound, if we have sulfur, it'll be SO2 gas, and so forth. Now, the biggest challenge with balancing in combustion reaction is honestly balancing the oxygen, so we save it for last. So let's say we had C2H6 gas plus O2 goes to CO2 gas plus H2O gas. Easiest thing to do first, balance the elements on the left with the product gases on the right. There's always going to be something bound to a pure element. Oxygen always bound to a pure element. So if we look at carbon, we've got 2 carbons, so we want to put a 2 here. Hydrogen, we've got 6. We need a 3 here, get us to 6. The challenge here is the oxygen. We don't want to end up with a fractional coefficient on the oxygen, but let's solve it. We have some coefficient in front of this oxygen here. Let's call it A. And we've got, for every A we have, every O2 molecule we start with, we produce 2 oxygen atoms. This has to equal the number of oxygen atoms here on the right. So for every CO2 molecule, we've got 2. So this is a total of 4 from CO2. And for water, we've got 3. 3 water molecules, 3 oxygen atoms. So we've got 2 times the coefficient on oxygen equals 7, so the coefficient on oxygen is 7/2. That's fine, because all we're going to do as a last step is multiply this whole reaction in such a way that we cancel out any fractional coefficients. Now, since we have a 7/2, the easiest thing to do is multiply everything by 2. So 2 C2H6, this will give us a 7O2, 4 CO2, and 6 H2O. The only way to make these problems more complicated is to give you oxygen and a starting compound. So let's say you decided to combust formaldehyde. So CH2O gas plus O2 gas goes to CO2 gas plus water gas. We're going to do the same thing we did before. Start by balancing our carbons. So we've got 1 carbon here, 1 carbon here. We're done. Hydrogen, we've got 2 here. We've got 2 here, so we're balanced. The question now is oxygen. Now again, we're going to guess some coefficient on oxygen A, and we're going to have twice that many oxygen atoms. But we also need to drop down how many we got from the parent compound. So we're just going to use the subscript on O and say that we have 1 here. So 2 times the coefficient of oxygen plus however much oxygen was there in the starting compound. This is going to equal how much oxygen we have from CO2. In this case, we've got 2 atoms. And how much oxygen we have from water, in this case 1. And again, we're just going to solve for our coefficient on oxygen. So our 1's are going to cancel out. We'll get twice the coefficient on oxygen equals 2, or the coefficient on oxygen is 1. And that's our solution to it. Again, with combustion reactions, balance the non-oxygen elements first. Say balancing oxygen for the very last step. If you end up with a fractional coefficient, which is a very likely possibility with CO2, with combustion and oxygen, once you've balanced everything, figure out what your fractional coefficient is on oxygen, multiply by its denominator. So if you have 7/2, multiply by 2. If you have 3/4, multiply by 4. Distribute that multiplication across the entire reaction, and you'll be done balancing the reaction.